area and volume. And I had to obviously consolidate these into a more compact unit because of the whole week off with the extra ice and everything, right? So this is going to be quite a push to the end here, ladies and gentlemen. But you can see pretty much everything is laid out. What do you need to do if you miss a day?
Make it up.
Make it up. It is your responsibility, okay? The videos are posted. Everything is Delta Math, mostly. So there's a couple of worksheets, but it's mostly Delta Math. And then we have a test, and then some final exam review days, and then finals, and that's it. There will be test corrections, which you can still do. So today, test corrections. All right. So please don't do test corrections while I'm teaching. You really should be taking notes. Okay. The nice thing is that because I had to consolidate. These are my notes, meaning I had to make them. So they're shorter. I'm trying to make them as painless as possible, give you the most time to get stuff done, right? Thank you. Yeah, I do try.
I actually admire you because you took your time out of your day to make your notes.
I do try to make it easy on you. Okay, so today we are talking about areas of circles and sectors, okay? And we have some area puzzles that we're looking at. So here we have example 1, find the area of the circle or area of the sector. So we have a couple of questions here. Area of a circle, we've already done area of a circle. What is the formula for area of a circle? Pi r squared. Very good. And what does r represent? Radius. Very good. Pi r squared. Very good. And just as a reminder, what is circumference of a circle? 2 pi r. Yes. Okay. And again, it's very closely related to our area formula. If all you have to do is drop the 2 in front, and that's circumference. Okay. But we're talking about areas today. Now, sector area is asking, hey, I have a circle, and maybe we have the center of our circle is there, and all I want, is it missing a page? Oh, craziness. Okay, thank you. What I want is maybe just a portion of the circle. Hi, not the whole thing.
I'm trying to finish a project before the end of the year, so could I do that?
You may, okay. But here's the notes.
Okay, thank you.
All right. So what we want is just to find this little section of area, not the whole area of the circle, but just a little section. Well, we have done something similar to this as well, and that is if we want the area of just a sector of a circle, then we create these little fractions, these little proportions that we can do here. That's just a portion of the total area of the circle. So it's just a little piece of the whole area, which we know the whole area is pi r squared. And maybe we know that this angle is a central angle, and maybe it's x degrees. Well, so that'd be x degrees out of how many degrees in a circle? 360 degrees. So again, we create this little proportion that's really just comparing part of the circle to the whole thing, okay? A part to a whole. Now, and so that's what we're going to use today. Here, for letter A, let's look at this question. It says the diameter of a circle is 6 feet. I'm going to write down, then D is 6 feet. Does diameter help me here? What do I need? What's more important?
Circumference.
Well, no, we're trying to find the area. I need the area. That's what I'm trying to find. What's my formula for area?
Square, pi r2.
Pi r squared, very good. And, there's no d in this formula for area. What do we need to do? Yeah, find the radius. What is the radius? 3. How do we get 3? Divide it by 2. So we get the radius is 3. And all I need to do then is take that radius and plug it into our formula. So pi times 3 squared. And it says find the area in terms of pi. What does it mean when it says in terms of pi? You keep the pi. Yeah, you keep the pi. And so all I have to do is, what is 3 squared? 9 pi. And the pi just gets to stay there, and it's this beautiful answer that is 100% perfect. It's absolutely perfect. When you plug in 3.14 for pi, you just approximated it. It's no longer perfection. So it's off. Just a little. Okay. All right. But this is totally exact. Divide by 2?
Oh.
Right? Because the diameter is big and the radius is small. Yeah? Okay. All right. So now letter B. We have circle J with the measure of angle HJK is 122. HJK right here. So this little central angle is 122 degrees. And we have HJ is also 16. See, HJ, that's the length of the radius. Very good. So the radius equals 16. And it wants us to find the area of sector HJK. HJK is the area of this little wedge of the circle. So we just want to find that sort of shaded area. And we went around to the nearest hundredths. So this is sector area. So I'm using this sort of proportion model to set up, okay? So I need to figure out the area of this sector. I'm going to just do A sub S. That's what I'm trying to figure out. Sector. We can write sector, sect if you want, yeah? Area of the sector over, what's the total area of the circle? Pi times r squared. All right. What is our radius? 16. Okay. So again, I'm using this model, and all I'm doing is plugging in our radius. Okay. And then that's equal to our central angle. What's our central angle? 122 over what's the total number of degrees in a circle? 360. It's all it is part to whole. Part of the area to the whole area. Part of the central angle to the whole angles. Like that's all we're doing, okay? How do you get the area of the sector isolated? Yeah, we cross multiply. And really all I need to do is take this and multiply it right to the other side. And then that area of the sector is all by itself, and that's what we want. So area of the sector is 122 times pi 16 squared divided by 360. And of course, we can just put all that in our calculator. 122 times pi times 16 squared and divided by 360. And that is 272. And we went around to the nearest hundredths. That's 2 decimal places. So 0.55. Okay. All right. Any questions on those two things? All right. We've sort of done those sort of before. Now, example 2 is review. Evidently, you have learned these things before. You need to write down these formulas because you're going to need them. Find the area of each plane figure. A plane figure is a 2-dimensional figure. These are common figures that you've had growing up. And so in this, letter A, we have a square. And so we have a square. What do you know about a square? All sides are the same. Okay? And so I'm going to just call it S for side. What is the area for a square? What's the formula for the area?
Pi R2.
No. It's S squared, yeah. It's a rectangle. The formula for the area of a rectangle is base times height. In this case, our base has a S and our height has an S. So it's just side times side, or side squared. If our side is 3 inches, what do I need to do? Three squared. 9. This is 9 inches squared for my area for letter A. That's all. Okay? All right. We have a rectangle. In a rectangle, however the shape of your rectangle is, whether it's laying down like this one is, or standing up nice and tall, the formula that I like to go with is whatever your base is times whatever your height is. And it's really important that we understand that we're talking about a height that is perpendicular. It must be perpendicular when we're talking about heights, okay? The formula for the area of a rectangle is base times height. How many of you grew up with length times width? Yeah, I hate that. Base times height. Get used to it because we're going to use it often, okay? Means the same thing, but base times height, we're going to use over and over. It's the foundation of everything, okay? So this is the formula for the area of a rectangle. So we have in our rectangle a base of 5 and a height of 7. What do I need to do to find the area? 5 times 7. Base times height is 35 centimeters squared. Okay? All right. Parallelogram. Anybody know the formula for the area of a parallelogram?
Everything times 6. Wait, what's a parallelogram again?
What's a parallelogram?
I forgot.
All right, here we go. Parallelogram. Get the whole unit on. Oh, yeah.
My brain's like dead right now.
Yeah. All right. All right, there we go. I drew a picture of a parallelogram. Does it look different than a rectangle?
Yeah.
A little. Okay, it's a little slanty, yeah? All right. So here's the thing, though. You can imagine if I were to take a parallelogram and if I were to drop down in altitude and cut that little triangle off. And if I take that triangle and I sort of pushed it over here to the end, it would fit in right here real nice, wouldn't it?
Yeah.
Uh-huh. All right. So it becomes, we don't even have to, when I take this little triangle off and slide it over here to the end, it's a rectangle. Okay? We turned a parallelogram into a rectangle. And so it turns out that as long as you have the base length, which is our blue length here, and we have to have this perpendicular height. All right, I need a perpendicular height as opposed to this sort of slanty bit. I don't want the length of that, okay, but I need a perpendicular height. And it is still going to have the same formula. It is just base times height for a parallelogram. So here we have a parallelogram with base 10 and height 8. So what do I have to do to find the area? Multiply. 10 times 8 is 80 feet squared. So parallelogram just morphs into a rectangle, which is kind of cool. Space times height. As long as, yeah, we always have to understand that height has to be perpendicular. We want a straight up and down height, nothing slanty yet. All right, we have a triangle. And this triangle, a triangle can be any sort of shape, but I'm going to say it's a right triangle for now. Right triangle means it's got a right angle. Okay. So let me ask you a question. Do you know the formula for area of a triangle?
Yes.
What is the formula for area of a triangle?
Wait, it's like length times.
That's Pythagorean theorem. We're talking area. It's a long time. Okay.
Wait, can you times it by 2 and then just use it as like a square?
That's a good thought. Can you times by 2 and is it a square? James, what do you got?
8 times 9 divided by 2.
Divided by 2. Okay. So yes. What's going on here? Well, if I have a right triangle like this, and I'm going to say again that I have the base B, and this is my lovely little perpendicular height H. Now, you'll notice that if I can pretty easily sort of turn it, if I were to multiply base times height, I would get a full rectangle. Well, what do you notice about this rectangular shape? It's like a square or a rectangle, okay. But tell me about then just the triangle right here. Is it the whole thing? It's only half of that rectangle. And so that's where, again, that formula comes from. The area of a triangle is just half base times height. 1/2 base times height, or base times height over 2, okay? All right, so then our area is going to be 1/2, a base of 8, and a height of 9. So 1/2 of,
times it by 2.
yeah, divided by 2. We get 36. In this case, it's square centimeters.
Oh, because that gives us the whole thing.
Yeah, well, base times height gives us the whole rectangle,
Okay.
but we only want half of it, because we can cut any rectangle diagonal-wise, and it'll be a triangle. All right, the last one is a trapezoid, and I'm going to, again, trapezoid. A trapezoid has traditionally 2 parallel sides. Those are called the bases. So I'm going to call it base 1, base sub 1, and base sub 2. Draw your picture, please, and label it. Base sub 1 and base sub 2. I am just going to give you this formula today, but it is a pretty easy thing to derive. And very important, we have a height of our trapezoid, and that height, again, has to be perpendicular, straight up and down, okay? So the formula for the area of a trapezoid is 1/2 the height times the sum of the bases. 1/2 height times the sum of base 1 and base 2, base 1 plus base 2. So you have to add them up. What we're doing is we're actually taking an average of the bases, adding the bases and dividing by 2 times the height. All right, so on this one, for the area, we have bases 12 and 18 and a height of 7. So I have 1/2, my height of 7, and then I need to add my bases together, so 12 plus 18. And again, I can plug all that into my calculator pretty nicely. I'm going to use 0.5 for 1/2, and then 7 and 12 plus 18 in parentheses there, and we get 105. And again, it's in, what are we, oh, I didn't have units on this one. 105 units squared. Okay. Questions on those? Did you copy down all the formulas?
Yeah.
Okay. Keep those handy because you're going to need those formulas. Very important. And now we get to the hard stuff.
Oh.
It's not hard, though. It's more fun. These are puzzles.
Oh.
So, example 3. We want to find the area of the shaded region, and we're going to round to the nearest tenth if necessary. So we only want the shaded region. Tell me what figures you see in letter A. You see a square, and you see...
Not a triangle.
They're not triangles. In a circle. We see a giant square, and we see an inscribed circle. And I see some 7s. What is this 7 representing?
HK.
The segment HK, the length there. And this 7 is length KJ. So we absolutely have a square, all right? And, So how do you think we're going to figure out the area of just these little shaded spaces?
Could just like get the whole square and divide by 60.
So we are going to do something with the whole, the area of the whole square to start. So if I get the whole square, I have this whole area, all of this space. But what do we need to do if we want to take something away? Remove a portion. Minus, yeah. So we're going to follow this sort of pattern where I'm going to find the area of the whole figure, and what I need to do then is to remove a portion. And in this case, I need to remove by subtracting the area of the circle. So I'm going to find the area of the whole thing, and then we can subtract away that white space. So what is the area of the whole square?
7 times 7.
Yeah, it is just base times height, so 7 times 7 or 49. And we are going to remove, what's the formula for area of a circle? Pi r squared. Okay, what's r? All right, the radius. Well, let's see. There is my radius. How big is that radius? Half of 7. Very good. 3.5. Remember, this whole thing, both radii make up 7, so we need to divide that by 2, so we get 3.5. So then we have pi times 3.5 and squared. And so I'm just going to plug this into my calculator. So the area of the square is 49, and we're going to subtract the area of the circle. And we want to round to the nearest tenth. So 49 minus pi times 3.5 squared. Just plugging it into our calculator, and we get 10.5. So there's the area of just the shaded parts. Okay? Questions on that one?
Nope.
No, let's look at B. All right, for letter B, once again, what are we trying to do? Find the shaded portion. So what do we start with? What's our process? Like over here, we're going to do the area of the square minus the area of the circle. What are we going to do on this one? Yeah, we want the whole figure. So the area of the whole circle minus, what are we going to subtract away? The area of the rectangle. All right. What's the formula for the area of a circle? Pi r squared. And what's the formula for the area of a rectangle? Base times height. Okay. Ooh, interesting. Here I have a circle, circle X, and, yeah. Okay, this is crazy here. We got some math to do. We have a big giant diameter here. And I have, what does that create when I draw in that diameter? A hypotenuse of a right triangle. Oh, what do we need to do to find the length of this hypotenuse? Pythagorean theorem. Leg squared plus leg squared equals the hypotenuse squared. You thought you were done with Pythagorean theorem, but no, you're never done. All right. So 9 plus 16 is 25 equals c squared. What is c? 5. So c is 5. This whole diameter is 5. The diameter equals 5. What's the radius? Yeah, the radius is 2.5. All right, so the radius is half of that. So we have pi times 2.5 squared. And what about the area of our rectangle? What's our base times height? It is 12. 3 times 4. I'm going to do that. 3 times 4, we get 12. What? Do you see that? Yes, there's our base and our height. Okay. Pi times 2.5 squared minus 3 times 4, which is just 12. You could just type that in. 7.6 for the area of the shaded region. Okay. Craziness, huh? All right, let's look at C and D, and then we're done. So, in general, we want to find the area of the big thing and subtract the area of the smaller thing, in general speaking. Or sometimes we think about it as the area of the outside thing or minus the area of the inside thing. There are so many ways to think about this that will work. So when we look at this, what's the area of the biggest thing? The outside thing? It's a circle. Pi r squared. And then the area smaller is going to be another pi r squared, but it's a different size thing. Let's see. I need to know, in this picture, they're giving me this tiny little radius here. Yeah, if you double it, you get the radius of the big thing. Yeah, so this is also 7. That whole thing from K outward is the radius of the big circle. So our big radius is 14. And so this is going to be pi times 14 squared minus our little circle, which is, what's the radius of our little circle? 7. So there's our little radius, which is 7. All right, so big circle minus little circle area. Let's see what we got. Pi times 14 squared minus pi times 7 squared. Turns out to be 461.8. Do you have any questions so far? No. You getting it? All right. This one's different. This one's a little bit different. We only want the area of the shaded region. And it's a very different sort of look to it. I can't just subtract away one figure. The whole thing isn't shaded, and I'm removing a single thing. So another way that we can find an area is to find miniature areas and add them together. Areas of pieces and add them together. So when I look, I see this figure right here, and what would you call this shape? Yeah. So the area of this triangle is 1/2 base times height. So if I can find the area of the triangle, then what I want to do is add this shape. What is this shape? A weird exactly quarter circle. This is 1/4 of a circle. You can see that it's 1/4 of a circle, right? And it's got a 90-degree angle, so 90 out of 360 is 1/4. So it is a quarter of a circle. So this is just 1/4 the area of a circle, which is pi r squared. I need to add these areas together, okay? So for the 1/4 circle, I have 1/4 of the area, which is pi. And what's our radius on this circle? 8. So there's my area of a circle, and when I multiply it by 1/4, that's 1/4 of the area. So that gives me the pink area, and then all I have to do now is add in my green area. If this is 8, that's like the base of my triangle. What's the height of my triangle? It is also 8. Yes, it is, because it's yet another radius. So that's going to be 1/2 the base of 8 times the height of 8. All right, and once again, So sometimes we're just going to add the areas together, okay? So we have 1/4 times pi times 8 squared plus 1/2 times, can I just do 64? Yeah, okay. All right, and that gives me 82.3, rounding to the nearest tenth. Okay. All right, do you have questions for me?
No.
All right, you have a delta math to do.